A very good morning students. So welcome to my next video tutorial. So this is the continuation video of mean value theorem, and in mean value theorem in our previous class we have started the chapter roles theorem. So few questions we will be solving from roles, then we will go to the next part of MVT, that is Lagrange mean value theorem, right? So you see I have noted down here one question. We have one function fx equals to x plus 3 e to the power minus x by 2, and we have to see whether this function is verifying Rolle's theorem or not at the closed interval minus 3 comma 0. Okay, so we have to prove this one. In the previous class already I have explained, in order to prove a function as a Rolle's theorem we need to satisfy or we need to fulfill three conditions. So first we have to prove that it is continuous, second we have to say that it is differentiable or it exists, and the third it should be f of a equals to f of b. If f of a, that means f of minus 3 is equals to f of 0, if both the values are same, then we say that these three conditions of Rolle's theorem are fulfilled. So therefore there exists a least value of x, say c, such that f dash c equals to 0. Okay, so in the question fx will be given. This question we have to differentiate, and in place of x we have to substitute c, then that is our f dash c, and whatever answer we are getting after substitution of c, we will make it equals to 0, and we will get the value of c. That c answer should be lying between minus 3 comma 0, not minus 3 not 0, it should lie between minus 3 and 0. Okay, so let's start the solution. Fx is a polynomial and exponential function, that means polynomial also here, exponential is also here, so it is continuous on minus 3 comma 0. F dash x exists on minus 3 comma 0. Now we have just written here exist on, because if a function is continuous it has to be differentiable, right? So therefore it exists in open interval minus 3 comma 0. In the previous video I have explained you what is the meaning of open bracket and closed bracket. I repeat, if it is, let us consider 3 comma or 1 comma 3, right? It is under closed interval. 1 comma 3 means the value of x can be 1 also, the value of x can be 2 also, value of x can be 3 also. That means extreme point as well as the point which is lying between the two extremes, right? So it can be 1.5, 2.5 also, or 2 also. Understood? So therefore if I say 1 comma 3, then the value of x has to be 2 or 1.5. That means that has to lie between 1 and 3. It cannot be 1 and 3, right? So this is the meaning of open interval and this is the meaning of closed interval. So therefore it is continuous, it exists on, and third point we have to find f of minus 3. We will substitute here minus 3, here also minus 3, and minus minus plus, that is 3 by 2, right? So minus 3 plus 3 is 0, 0 multiplied by something is 0, so therefore f of minus 3 is 0. Simply when you substitute here 0, that means 0 multiplied by something non-zero value, you will get 0 only. So directly I have written f of minus 3 0. So you see f of minus 3 is also 0, f of 0 is also 0. So both the values are same. So I have written here, as three conditions of Rolle's theorem is satisfied, so there exists a least value of x, say c, such that f dash c equals to 0. So f dash c equals to 0 means we have to take that function, I have multiplied x within the bracket, then I have differentiated by applying product rule, right? This is our u and this is our v. U or u ddx of v plus v ddx of u. So this is under bracket. Now you see, from the whole term I have taken e to the power minus x by 2 common. Now if I take this part common, then we will be getting here 2x plus 3 plus minus minus, that is half is outside, x squared plus 3x. Now f dash x is this one, so f dash c will be, in place of x we will be substituting c everywhere. Now f dash c equals to 0. So from this term if I take e to the power minus c by 2 common, so 0 by e to the power minus c by 2 is 0. So only we will be getting this term. Now in the second step I have taken here LCM. LCM is 2. So if I take LCM and if I cross multiply 2 into 0, 0, right? So 4c minus 3c is plus c. c plus 6 plus minus c square equals to 0, and we know in any quadratic equation if the coefficient of c square is negative, so we need to make it positive. So minus c square, if I take all the terms in the right hand side, then minus c square will be plus c square, plus c will become minus c, and plus 6 will be minus 6. Okay, now we will take splitting middle term. 6 1s are 6, here 6 1s are 6, that is in the table, multiplication table. 3 minus 2 is 1 and 3 2s are 6, right? So here nothing is there, means 1, so therefore 3 minus 2 is 1. So by splitting middle term we got the value 3 comma minus 2, that means c value can be 3, c value can be minus 2. Now let's see what is our range. Our range is minus 3 comma 0. So 3 won't be lying between this, so the value which will be lying between minus 3 and 0 is minus 2. So therefore our answer is c equals to or minus 2, which belongs to minus 3 comma 0. I repeat, c equals to minus 2, that means the value of our c is minus 2, which belongs to minus 3 comma 0. C does not belongs to 3, that means c value cannot be 3, right? So this is the solution of this question. So on the screen you can see the next question. If Rolle's theorem holds for the function fx equals to x cube plus bx square plus ax plus 5 on the closed interval 1 comma 3 with the value of c equals to 2 plus 1 by root 3, find the value of a and b. Okay, so listen carefully. This question already it is said that it holds true for Rolle's theorem. That means we don't have to prove the three conditions, that is continuous, that is differentiable, and the f of a equals to f of b. In this question we need to find the value of a and b, right? So the function is already given here and it says that it holds true for the function. That means f of 1 equals to f of 3. So you see I have taken the first condition, f of 1 equals to f of 3. We know fx equals to x cube plus bx square plus ax plus 5. So in here in place of x we will be substituting 1. Okay, so we will be getting in with respect to 1. Now same function we will be substituting 3, that is 3 cube plus b 3 square plus a into 3 plus 5. So after solving this one we will be getting one equation, that is with respect to a and b. So here everything I have taken to right hand side. Now after simplifying it, after taking 2 common here and 0 by 2 is 0, therefore a plus 4b plus 13 equals to 0. So this is the equation number 1. So this equation 1 we got from the first condition, that is here it is first condition but it is the third condition of Rolle's theorem, right? So f of 1 equals to f of 3, from there we got equation number 1. Now let's proceed to the next part. You see, after proving the three conditions we need to write as three conditions of Rolle's theorem were verified or satisfied, so f dash c must be equals to 0, right? So that condition I have taken again here, that means f dash c equals to 0. So we know in order to find f dash c, first we need to take fx, we have to differentiate that. After differentiation in place of x we will be substituting c. So same way I have done here. Fx was this one. Now f dash x, that means we have to differentiate this one. See, differentiation of x cube is 3x square, differentiation of bx square is 2bx, differentiation of ax is a, and differentiation of 5 is 0, right? So we got f dash x. Now in place of x we will be substituting the value of x, that is c. Now that is 3c square plus 2bc plus a, right? Now in this question again you see the value of c is already given here, so we need to substitute the value of c again here. So f of c means f of 2 plus 1 by root 3. So in place of c I have just substituted the value. Now we know here a plus b whole square formula means we have to expand that one, right? So you see 3 I have kept out as it is, that is 2 square, that is a square plus b square plus 2ab, right? Now 2 into 2, that is 4b, 2b by root 3 plus a as it is. Now I have simplified in the next step here, that means 2 square is 4, that means 1 by 3 root 3 whole square is 3, that's why 1 by 3, 2 to the 4, 4 by root 3, and this one as it is. In the second last step I have multiplied 3 here, 3 4 is 12, 3 and 3 will get cancelled, that is 1, and 3 4 is 12 by root 3 plus 4b plus 2b by root 3 plus a as it is. Now you see here a 4b 12 plus 1 13, so that means a plus 4b plus 13 I have written as it is here. Now these are the terms left, these are the left terms. Now you see the interesting part of this question is that a plus 4b plus 13 already I have made it equals to 0. That means in the second equation when I get a plus 4b plus 13, then in here I will be substituting directly 0 here. Okay, that means this one I have solved here, that means 0 plus 12 by root 3 plus 2b by root 3. Okay, so let me make it clear here. This part I got here 0 plus 12 by root 3 plus 2b by root 3 equals to 0. So if I take one term in the right hand side, then I will be getting minus 2b by root 3, right? So root 3 and root 3 will get cancelled. 2 1 are 2, 2 6 are 12, that is b equals to minus 6. So b value we got minus 6. Now we need to find the value of a. So this minus 6 I will be substituting here, then I will get the value of a. So let's substitute here. So a plus 4b, b is our minus 6 plus 13 equals to 0. That means a minus 24 plus 13 equals to 0. That is a minus 11 equals to 0. Therefore a equals to 11. Okay, do not get confused. First I have written here, then this part I have solved here, and last answer is there. So that is what is the value of a. The value of a is 11 and value of b is minus 6. Okay, so few students have sent me this doubt from the Rolle's theorem. They were facing problems, so I have solved on the board, right? So this type of questions, first you will use the third conditions of Rolle's theorem, f of a equals to f of b, then you will be getting one equation. Then in the second part, see the value of c will be given. If given, then you substitute that value and you interrelate both the equations, then you will get the value of unknown terms, right? That is a and b. So on the screen you can see Lagrange mean value theorem. So in this theorem it is said that if a function fx is defined in closed interval a comma b is such that fx is continuous in a comma b, fx is derivable in open interval a comma b, then there exists at least one value of c of x within the interval a comma b such that f dash c equals to f of b minus f of a divided by b minus a, right? So the formula has changed. You see, in the Rolle's theorem we have taken the condition f dash c equals to 0, but here in LMVT, that is Lagrange mean value theorem, we need to take here f dash c equals to f of b minus f of a divided by b minus a, right? So first two conditions more or less they are same. That is, first we have to prove that it is continuous in closed interval a comma b. Second condition, it is derivable in open interval a comma b. And the answer which we will be getting, that is value of c, that has to lie between a and b, that is in open interval, not in closed interval. Okay, so let's proceed to question of Lagrange. So fx equals to x square minus 2x plus 4 in closed interval 1 comma 5. So we have to prove here LMVT, that is Lagrange mean value theorem. Okay, so first we will be writing here fx is a polynomial function, so it is continuous in closed interval 1 comma 5, right? Next point, fx is derivable on open interval 1 comma 5. So these 2 points we have written. Then there exists a least value of x, say c, such that f dash c equals to f of b minus f of a divided by b minus a. So one thing you note here, in Rolle's theorem first we have proved continuous, then we have proved differentiable, then we have proved f of a equals to f of b. But here third condition is not there, f of a equals to f of b, we don't have to check. Now if in the question f of a equals not equals to f of equals to b, then remember that will be solved by LMVT generally. But if they both are equal, that means f of 1 equals to f of 5, then that question will be solved by Rolle's theorem. Okay, sometimes in the question it is not mentioned that verify Rolle's theorem or verify Lagrange, just it might be written that verify that is mean value theorem. Okay, that means in that question we have to check whether the question is from Rolle's theorem or Lagrange. So we will be testing the value of f of 1 and f of 5. If both are equal, I repeat, that will be solved by Rolle's theorem. If both the values are not equal, then we will say that that question will be solved by Lagrange, right? So this is the condition. Now f dash c, that means first we need to find here f dash x. So fx we know x square minus 2x plus 4. F dash x will be 2x minus 2. Similarly, f dash c will be 2c minus 2. F of b, now let us find the value. One by one we will find all the values, then we will substitute here. Let us consider this is equation number 1. So f of b, in place of b we have 5, right? So this 5 we will be substituting here, that is 5 square minus 2 into 5 plus 4, that is 25 minus 10 plus 4, that is 29 minus 10, that is 19, right? Similarly, f of a, that is f of 1. So if I substitute here 1, that is 1 square minus 2 into 1 plus 4, 4 plus 1, 5, 5 minus 2, that is 3, that is f of 1 equals to 3. So f of 5 is 19 and f of 1 is 3 and f of c is 2c minus 2. So first value, second value and the third value. So these all values will be substituting in f1, or that is f dash c. Substituting value of f dash c, f of 5 and f of 3, we get f of 3 in equation 1, we get, that is in place of f dash c I will be substituting here 2c minus 2. In place of f of b I will be substituting here 19. F of a, that is f of 1, that is 3, and divided by, you see, b minus a. What is our b? B is our 5 and our a is 1, that is 2c minus 2. 19 minus 3, that is 16. 16 by 4, 4 4 is 16, that means 2c minus 2 equals to 4, or 2c equals to 2 plus 4, that is 6. 2 1 is 2, 2 3 is 6, that means c value is equals to 3, which belongs to open interval 1 comma 5. So this is our answer, right? So c value is equals to 3. C value is equals to 3, which belongs to 1 comma 5. So you see the last answer that should be in open interval, that is between 1 comma 5. So next question, you see fx equals to e to the power x on 0 comma 1. So again for this question we had to prove LMVT. So first we will say that fx is continuous. Fx is continuous on open interval or in the closed interval 0 comma 1. Point number 2, fx is derivable on open interval 0 comma 1. Then we need to write that statement. Then there exists a least value of x, say c, such that f dash c equals to f of b minus f of a divided by b minus a, right? So f dash c means fx. So differentiation of e to the power x is e to the power x itself. Now if I substitute it here c, then we will get e to the power c, right? Now f of b, our b is 1, that means this one I will be substituting here, then I will be getting here 1, e to the power 1 minus a value is 0, that means e to the power 0 divided by 1 minus 0, right? So e to the power c equals to e minus 1. Now you see e is there, if it changes its side then we will be getting log, that is log e minus 1. So this is our answer, which belongs to 0 comma 1, right? So last answer, that is c equals to log e minus Next question. Find the point on the graph of y equals to x cube where tangent is parallel to the chord joining 1, 1 and 3, 27. Now you listen here. So there is one curve. Let us consider this is the xy plane and this is the curve. Okay, the curve equation is y equals to x cube where tangent is parallel to the chord joining the points 1, 1 and 3, 27. Let us consider this is the point which we need to find in this question. So a tangent is drawn from that curve and we need to, and now condition is given in the question, this tangent and the point that is 1, 1 and 3, 27, the line joining these 2 points and these 2 points are parallel to each other. Okay, so we need to find the point P here, right? So let us consider the point P is x and y, that is x, y. Okay, so we need to find x and we need to find here y. So you see this question will be solved that by LMVT. We apply LMVT for the function fx equals to x cube in closed interval 1, 3. So we say that this function is continuous in closed interval as it is a polynomial. Next it is derivable in open interval 1, 3. Now thus both the conditions of LMVT are satisfied, right? So these are the two only conditions of LMVT. So there exists a least value of x, say c, which should lie between 3, 4. Okay, 3, 4 means here 1, 3 should lie between 1, 3. Now listen here, 2 points were given in the question. So we need to take x of first, x of second point. Okay, the point should lie between apsica of first point, apsica of second point. That means our point will be 1, 3. Suppose in case if the limit it would have been 2, 3 and 5, 10, then our next limit will be 2, 5. That means we have to take 1. Till now we have solved questions where only 1 point was given. But here you see whenever 2 points are given, so we need to make the third point by taking only x value, that means 1, 3. Like example 2, 3 and 5, 10, we need to take here 2, 5. So we have to prove that question keeping our limit 2, 5. For example in here we have to keep 1, 3. So our point was 1, 1 and 1, 27, right? So therefore we have taken here 1, 3. So 1, 3 here, right? So such that f dash c equals to f of 3 minus f of 1 divided by 3 minus 1, because 3 is our b now. 3 is our b and 1 is our a, right? So f of 3 means f of x was x cube, so that's a 3 cube. F of 1, that is 1 cube, that is 1. Now f dash c, fx was x cube, so ddx of x cube is what? 3x square. Now if I substitute the term c there, then we will be getting 3c square. Therefore 3c square equals to 27 minus 1 by 2. These values we got by substituting 3 and 1 in the question. Question was x cube, right? So 3 cube is 27, 27 minus 1, 26, 26 by 2, that is 3 2 is 6. Now if I reduce, we will be getting 13 by 3. C square equals to 13 by 3, that means c equals to root under 13 by 3. I have rationalized this one. Multiplying by 3, we will be getting 3 into 3, out of square root we will get only 3, and 3 30 is 39, that means under root 39. So this value of c is our actual value of x. Now we need to find y, because we need to find here point, right? So substituting this value of c in the question, because fx means y here, so and x means the least value of c, so that is c cube. So our c was root under 13 by 3. Now c cube will be root under 39 by 3, root under 39 by 3 into root under 39 by 3. That means cube is there, so I multiplied 3 times. So 3 3 is 9. So root 39 is 39, and this one will be as it is. 3 13 is 39, that is 13 root under 39 by 9. So this is the value of y. So we know x value is this one, that means the value of c is x, and this is the value of y. So our given point is root under 39 by 3, comma 13 root under 39 by 9. Okay, so whenever the question is find the point on the graph of this curve, then we will see the points, 2 points by which the chord is joined. So we will take x of one point and x of the other point, that is our limit. So these are the Lagrange questions. You see question number 1, that is x minus 2 in 1 comma 2. So these are the questions, same way you will be solving. Right, question number 9, that means we have to find the value of c. Already it is said that it holds true for the Lagrange. So fx is given, so we will differentiate, then we will substitute c there, f dash c will make it f dash c. F of 6 means 6, so I will be substituting here, 4 we will substituting here, then all the values will substitute, then we will get the value of c there. Okay, so question number 10 I have solved just now, y equals to x cube, joining the points. Similar type of question, now just the function has changed. So 2 points are given, 1 comma minus 2 and 2 comma 2. So for this question we need to take their limit 1 comma 2. Okay, so you need to solve up to question number 10 only. Okay, so the questions I will be giving in your WhatsApp group also. So for this class only this much. So I'll also giving some practice questions. So those practice questions also you need to solve in your exercise book.